Okay, so my name is Igor. I'm a postdoctoral fellow here at University of Saskatoon, and I'll talk about emerging pests of honeybees. Specifically, I'll talk about three invasive species, very interesting species, and that have been even hot topics on the media lately. I'll start with the small hive beetle. We are talking about here of Aetina tumida. This is the scientific name of this beetle. It's an insect originally from sub-Saharan Africa, the region highlighted here in dark gray. This is a pest of honeybees because its larval stage can feed on the stored honey, pollen, and also brood. It usually affects only stressed or depopulated colonies. So it's considered a secondary pest here. And it has been scattered all over the world. Here in this map, we see different arrows. Those arrows represent introduction events. So we see that we already have records of this beetle in USA, Canada, some parts of Europe, even Australia. Regarding the cycle, it usually starts with a female adult beetle laying eggs on the frames. We can see this, it lays like a mass of eggs. In 2 to 4 days, those eggs will hatch into larvae, and they will start feeding on stored pollen or honey, or even brood. And around 10 days, those larvae will crawl out of the hive because they pupate in the soil. So they look for the ground and they go there and they will spend around 6 weeks there until they, a new adult beetle will emerge and will look for new colonies to invade. The adult form is really efficient flying, so it can spread throughout apiaries very efficiently. A little bit of information on for the identification of the species. Usually it presents 5 millimeters on size when it comes to the adult. And it has this very characteristic oval shape, as we see here. The color is usually reddish brown to black. And larvae would be cream color to golden, and they can grow to 1.2 centimeters. It's important to notice that this larvae can be mistaken for the wax moth larvae, but this one should be a little bit smaller, and the wax moth larva should present protopods at the back part of their body. This is the mass of eggs that usually is laid on the frame, and this is the pupal stage that goes into the ground. It's important to highlight that both adults and larvae, they are attracted by volatiles, products of fermentation. So usually debris of honey or pollen can ferment and produce those volatiles, and they are very attractive to this kind of beetle. Damage, as I said, the larvae is the form that will cause the damage, and they feed on the stored food. Here we see, as we see here in the pictures. Colonies are usually able to stand moderate infestation. Economic damage usually occurs when the hive or the colony is weak or depopulated for any reason, and there's not enough bees to remove or to remove the beetles or the larvae, or to protect the frames, right? Even when the larvae don't destroy the comb, it can introduce yeasts that cause fermentation of the honey, so it can spoil the honey even if they don't destroy everything. And those animals are pretty interesting because they can use their antennae to stimulate the bees to feed them. They mimic drones, so they are quite used to do this, and they are very good merging with the bees within the cluster, and they can overwinter together, the bees, and they can survive through the winters. When it comes to here in USA, as I said, those beetles are considered a secondary or opportunistic pest. They were first introduced in Florida in the 90s, and since they have spread throughout the USA, but they are particularly prevalent in the southeast part of the country. Methods of control, usually prevention is enough. Prevention is a very good option. So as I said, they are attracted to fermentation volatiles. So it's a very good idea to maintain a clean apiary and honey house, especially removing honey and pollen debris. When it comes to, and also keeping, as I said, usually weak colonies are affected. So keeping strong colonies is a very good idea in this case. So prevent any possible stress, for example, treat bees against parasites and also pathogens, and also try to propagate stocks that that present high frequency of hygienic traits. They're very good dealing with this kind of pest. When it comes to traps, there are many kinds. I'll talk about this one. It's kind of a recipient in which you can put oil inside, and you can fit those traps in between the frames. Usually those traps, they come with tiny holes. So when the beetles are running away from bees, they can fall into the trap, but the bees won't fall there because the holes are too tiny. And the beetles will drown there. As I said, the pupal stage is in the soil. So there's another recommended control method, which is the use of permethrin, which is an insecticide, around the colony. There's also the possibility of chemical treatment in the hive, and for that, Comaphos strips are recommended. As Elmer said, this is one possibility for treating also Varroa destructor. But I recommend a little bit of caution here when it comes to introducing Comaphos to a hive, because we already have a few cases of resistance of Varroa to Comaphos. Moving on to the Asian Giant Hornet. Those hornets were pretty popular in the media lately. Media has been calling it the murder hornet, or even death on wings. Pretty drastic names. We are talking about the Vespa mandarina. This is the scientific name, but it's also known as the Japanese giant hornet. They are the largest species of hornet in the world, and they are native to temperate and tropical areas of Asia. As hornets and wasps, they are predatory. They hunt most likely insects, so they can feed their larvae. And specific, this genus Vespa is compiles social wasps. So when it comes to the colony of this wasp, it would be, the setup would be pretty much similar to a honeybee colony. So you have there a queen and hundreds of workers. Identification. I believe the most remarkable feature of this hornet is the size, right? Usually it presents 4 centimeters in length, and the queen can be up to 5 centimeters. Here I placed the Asian hornet together with other common species of wasp that we can find here in North America. For example, the Western yellow jacket and the bald-faced hornet. And we can see that the size is pretty much discrepant, right? And the Asian hornet's way larger. Here, just for reference, the size of Apis mellifera. Yeah, they usually present these brown to orange shades, and they live, as I said, in society. They live in those nests, as honeybee do. And this is a picture of part of a nest, and those are the larvae of this giant hornet. Usually, they forage around 1 kilometer radius from the nest. When it comes to risk to honeybees, these hornets, they prey on insects, right? And if we think as a hornet, we would think that a honeybee colony is almost like a banquet for them, right? There's a lot of food together at the same spot, right? Usually the attack happens when a forager, one hornet finds a colony, and to start capturing bees from the entrance and taking back to their nest. But this attack can be somehow guided or assembled. When this happens, hornets will kind of mark the way to the colony, and even mark the colony that they want to attack. So other nestmates can be guided and find this honeybee colony. There are records that when this kind of attack happens, for example, dozens of hornets are able to kill an entire colony in less than 24 hours. Even when the colonies are not destroyed, completely destroyed, and only 1 or 2 bees are removed from the hive, most frequently the hive quits foraging. They focus on the defense of the hive. And also they become very aggressive, very defensive. So opening hives when you have wasps around can be quite painful. This is a picture of the Asian honeybee, the Apis cerana. In this case, we see that those bees, they have like a very interesting defense mechanism against the wasp. Those bees, they are native to the same area that the wasp is native, so they kind of co-evolve together. So they had the chance to come up with defense mechanism against the wasps. In that case, they kind of pile up on the wasp. They kind of produce this ball, and they move their muscles to produce heat. Here's a thermographic picture of this mechanism, and we see that they can heat up to close to 50 degrees inside of this ball. They kind of cook up the wasp inside of this ball. European honeybees, they haven't evolved together with this wasp, right? They evolved in a different environment, so they don't present this kind of defense mechanism. When it comes to risk to humans, accidents are quite rare. They're not usual, and even relating to humans or pets, because those hornets, they present a defense behavior when they are defending their nest. But there are records of deaths caused by multiple stings of this hornet, usually triggered by anaphylaxis or extreme intoxication. Here in USA and here in the USA, the first record of this wasp was in December of 2019 in the west part of those countries, close to the border, British Columbia in Canada, Washington State in USA. I believe there were other records of nests in the area, but for now we don't have any evidence of any other nest or the presence of this hornet here in North America. When it comes to control, I believe the only alternative is report to authorities, report to your state or province agriculture department. Because, yeah, beekeeping suits won't do the job if you're trying to remove a nest. Here is a picture of the one team that removed one of the nests, and we see that those are not beekeeping suits. So you have to be prepared. You have to have the adequate equipment to perform this kind of removal. And finally, I'll talk about Africanized honey bees. They were called killer bees for many, many years. Those bees are basically a product of multiple mating process of different subspecies of the Western honeybee, right? I will go into details in the next slide, but what we need to understand here is that this is basically the same species. European honeybees and Africanized honeybees, they are the same species. And they have a lot of morphological similarities. It's really hard to tell them apart just by looking. And when it comes to behavior and physiology, we will see that Africanized honeybees have a very similar behavior and physiology to the African bees. So that's the reason they're called Africanized. They're very adapted to tropical climate conditions, and we will see in the next slide how adapted they are. And yeah, today they are present basically all over America, the American continent, from central Argentina all the way up to southern USA. So for centuries here in the American continent, we had only European bees. Those bees were introduced through immigration processes. So the settlers brought their bees when they moved into the Americas. But in late 50s, Brazil was facing a military dictatorship, and the government was willing to increase agricultural productivity of Brazil, and beekeeping was also a target for them. And at the time, they decided to introduce a bee that would be more adapted to the climate conditions found in Brazil. At the time, European bees that were the only bees that we had at the time there in Brazil, they are not very adapted to the climate conditions there. They are not as productive there. So that's the reason they try to come up with the mix of bees that could increase the production of the area. So in the late 50s, they introduced a few queens there. The main goal was to kind of breed a gentle and productive strain of bees, but they had an accident. Accidentally, a few swarms escaped, and they started mating with the European bees that were already there. And we see that the product of this mating was really adapted to the region, so they spread really quickly. So like in less than 10 years, they took over Brazil and Argentina. In the 70s, they were already in Venezuela and Colombia. In the 80s, they took the Central America and Mexico, and they reached USA in the 90s. It's probably the most successful invasive species that we know. A little bit more information regarding the differences of Africanized bees and honeybees. As I said, morphologically, they are very similar. It's very hard to tell them apart. But usually, Africanized bees will present a reduced or smaller abdomen when compared to European bees. It can be highly variable, but it's one of the characteristics that we can identify. Regarding the development, Africanized honeybees usually take 19 days to complete their development from the egg to the adult, and the European bees would take around 21 days. When it comes to nesting, Africanized bees are less picky, so sometimes they would even present this kind of unprotected nest that would rank from a branch, for example. And European bees, usually they look for insulated cavities, for example, in trees, because they know that they have to protect themselves from the winter. Defense, which is probably the most remarkable difference of those bees. When it comes to Africanized bees, they are less tolerant to disturbances. And when they are facing a potential invader, they will react quicker, and they will mobilize many more bees, 10 times more bees into the defense of the nest. Africanized bees also swarm and abscond more frequently. They evolved the African bees, right, that share a lot of similarities when it comes to behavior with Africanized bees. They evolved in Africa, where the climate conditions are less predictable. So they kind of came up with this alternative to move when they find something that is not suitable for them. For example, it's too cold, it's too hot, or they cannot find enough food around, they will move. It's less frequent in European bees. And also tolerance to pests. For example, Varroa destructor, we will see that Africanized bees are way more tolerant to this kind of pest, and can be explained by many reasons. One of them, for example, they have like a shorter period of development, and possibly they present much more frequently high hygienic behavior. The impact and control of Africanized honeybees. They can produce potential negative impact on the native bees and wasps, for example, because those bees, they are very active, and they can potentially explore many more natural resources and compete with the native bees. It's important to highlight, to notice that European honeybees are also non-native to the area, to the Americas, and they can also compete with native bees. Swarming and nesting, as I said, the Africanized honeybees, they swarm and they abscond more frequently. So this process kind of increases the number of colonies occupying human-made structures, for example, power boxes on the ground or the roof of houses, and it can bring economic losses. Africanized honeybees also produce more drones, and their drones are better mating with European honeybees. So this process can produce what we call genetic drift. So the presence of Africanized bees in the area in a short period of time can lead to more and more bees presenting characteristics of Africanized honeybees. There's also a real risk of potential loss of animals and human lives. Accidents with Africanized honeybees are not that frequent, but they can be fatal sometimes. And as I said, it comes from the defense mechanisms of those bees. They are way more efficient reacting to possible intruders. So they react faster and they mobilize many more bees. They are also much more sensitive to vibrations and loud sounds. So it's very common for people that is mowing the grass and they don't know that there's a nest of Africanized honeybees in a tree or on the ground, and they get attacked. And those bees, they can also keep this defensive mode. Once they are disturbed, they can keep in a very defensive mood for long periods. It can last like 4 or 6 hours, way longer than European honeybees. In southern USA specifically, the control of Africanized honeybees is sometimes recommended. So if you don't have the familiarity with dealing with bees, the best option would be contact a professional to either destroy or remove the colony. And when it comes to beekeepers, a good option would be requeening. If you think that one of your colonies present this kind of behavior, it's potential Africanized honeybee, you can replace your queen with a mated European honeybee, and in a short period of time, they will switch back to more European-like behavior. It's also important to highlight that Africanized honeybees pollinate and produce honey as European honeybees. But if the alternative will be keeping and managing those bees, the skills required to manage Africanized honeybees are specific and they need to be learned. They are not the same as in European honeybees, but they are manageable. They can be productive. It depends on the area. It depends on the management system. With that, I finish my talk, and I'll leave this info here. There are many interesting, informative material here with very practical information, and you guys can check up if you want to get deep in one of those topics that I addressed in this talk.